Okay, so we're going to review these, okay? Let me pull up your test. Okay, it's gonna be 20 questions, so they're gonna be 5 points apiece. You'll have one question, but I guess it's 2 questions, but just one. Like number 1, I'm gonna give you like an A and a B for that. But just one like that, and then 1, 2, 3, 4, 5, 6, 7. I give you 7 simplify, like these. I give you 7 of these. So where you don't know where you're going type of thing, like you don't know when to stop. And then 1, 2. I give you 5 verify. So where you do know where you're supposed to stop, where you're making one side look like the other. And then I give you 4 sum and difference. Remember, you are going to have your sheet with you that has all of that. I'm going to hand that out with your test. It'll be part of your test. And then you'll have 2 like this, where literally all you have to do is read the double angle identities sheet. Okay? Also, I'm providing that to you as well. Okay? Any questions on format? No? Okay. You have to know your Pythagorean identities, your reciprocal identities, and your quotient identities. You're going to have room on the sheet that I give you that has the sum and difference identities. You're going to have room on that sheet to write down your other identities, so you can keep that with you throughout your test. You have to know those. If you don't know those, you're going to fail. I've gone through and highlighted some. There are definitely some that are starred. I wonder why I would do something like that. That's super weird. And then if you have any questions about any of them while you were working on, we can go over those. But all of them are pretty good examples of what could be on your test, okay? I have a note right here that says they are thinking too much about these. So you guys spent a lot of your time on numbers 1 and 2 whenever we worked on our worksheet, and we shouldn't be, okay? So the first one, both of them are good. Numbers 1 and 2 are good examples. I just picked number 1 because it was number 1. That was literally my train of thought. Okay, nothing fancy about it. It says that, I can't see over there, sine is the square root of 5 over 3, and tangent is negative square root of 5 over 2. I have to use my identities, and I need to find A, B, and C. Okay, so I can find, if I'm looking for cosine, then I know that sine squared plus cosine squared equals 1. So I can say this is the square root of 5 over 3 squared plus cosine equals 1. Okay, I need to square that. If you square a square root, you're just left with what's under the house, right? They undo one another. So 5 over 9 plus cosine squared. And then I'm going to subtract 5/9 from both sides. Okay. How am I going to write that 1? 9 over 9 minus 5 over 9. Right? So that's just me writing 1 with a common denominator of 9, right? And so I get cosine squared is 4 over 9. Take the square root. 2/3. And then if tangent is negative and sine is positive, where am I at? What quadrant? 2, right? And so am I positive or negative for cosine? Negative, right? So that would be your answer for that. So what is secant? -3/2, right? What is cotangent? -2 over the square root of 5, right? All I did, that was just flipping stuff. Okay? The biggest thing that I'll see on those is you guys forget to square sometimes. You forget to square. So don't forget to do that. If you remember to square, you'll usually get it. If you can find the which one you need to use, you can usually get it. I'm gonna look and see. Yeah. You're gonna use an identity, and then you're gonna be super smart. Okay? You're gonna use an identity for one. Should be pretty obvious. And then you're gonna have to think just a little bit. You might have to flip some stuff and use like tangent is sine over cosine or something. Okay? Any questions on these? The other one, I would find tangent first, I guess. And then you also have cosine, right? If this is, I also have this, right? So I could use that to find sine, and then I could always flip tangent and have cotangent.
Okay, for number 1, is it -2/3? And secant's -3/2, or is it positive?
It's negative.
It's negative.
Everything's negative. Because the reciprocal of secant is cosine, right? So if cosine's negative, then secant has to be negative. Only thing that should be positive is sine and cosecant, because it's in quadrant 2. Any questions on those two? No? Okay, your simplify ones, just some tips. I've already gone over these. If things are squared, look for a Pythagorean identity, okay? If they are not squared, you cannot use Pythagorean identity. On your test, there's going to be something that says sine plus cosine. And somebody's going to write 1. But that doesn't equal 1, does it? It has to be squared. If things aren't squared, you're probably going to use some algebra. So keep, change, flip, all that good stuff. And then turn everything to sine and cosine. Okay? If you get the problem and you don't even, and things are squared, but you don't even see an identity, everything to sine and cosine, use some algebra. Okay? This one has a star by it, so that's probably super important. I don't know. It just seems like something I would make important. Okay. What is tangent squared plus 1 equal?
Secant squared.
Mm-hmm. What about cotangent squared plus 1? Cosecant squared, yep. So those were identities. If I turned them into sine and cosine, I would have 1 over what? Cosine squared divided by 1 over sine. I'm going to keep, change, flip. I would write it like this. I'm going to flip flip sine up here. So that would give me sine it's squared, sorry. And what is sine squared over cosine squared? Mm-hmm. If you need this a little bit more, it would be 1 over cosine divided by 1 over sine. Then you keep change flip. Okay, that's keep change flip all written out. Okay. Another thing that you guys will do, and I guess it's because, maybe it's because like if I'm talking, I'm saying secant squared, cosecant squared, and I'm not really saying the x over and over and over again because I'm lazy and I have to say a lot of words throughout the day. You have to write an angle. Okay? Don't just write cosecant squared and no x or no theta. That's super wrong. There's no angle there. Okay? So make sure you write it. Okay, a couple different ways you could do this. One of them is definitely less writing than the other. What do you guys think? What? Yeah. This is an identity, right? So if I subtracted 1, what is cosecant squared minus 1 equal? We're confused, so I'm going to write it out. What does cosecant squared minus 1 equal? Hello? I have to post this on the internet, and y'all are making me look like a fool. Now I have to edit that out. Everybody okay with this? This is Pythagorean identity right here. Okay? So I can write this part as cotangent squared. I'm going to use the same theta, like that. Okay, then what do you think I'm going to do to cotangent?
Change to sine, cosine.
Mm-hmm. So it's what?
Cosine over sine.
What's my answer?
Cosine squared theta.
Mm-hmm. What else could you have done at the beginning? Let's say that you don't realize which, either y'all didn't feel like answering me or you didn't know that cosecant squared minus 1 was an identity. So let's say that you didn't recognize cosecant squared minus 1 was actually cotangent squared. What would you do? Algebraically, what are we going to do? We could distribute, right? Distribute, then we could turn everything to sine and cosine, and it would still work out the same way. So there's multiple ways that you can work these. Obviously, this one, if you notice it at first, it's less writing than having to distribute, then change everything. It's a little bit easier.
And it's more guaranteed to get the right answer.
Yeah, you can make less mistakes for sure if you notice the identity at first. 6, 7, and 8 are good examples. 7 does have a double angle identity, so I wouldn't give you one like that, but 6 is good, 8 is good. You just turn it to sine and cosine. What about this one, number 9? What do you think we should do?
I mean, we
Turn
turn
everything
it
sine,
then
cosine.
to sine, cosine, distribute. I mean,
Multiply?
yeah.
Mm-hmm. Okay. So what do we get right here if we multiply?
Sine square x over cosine.
Mm-hmm. Okay. Well, this is a fraction plus not a fraction, right? So we need to find a common denominator between these two. Okay? Which is what?
One cosine.
Is cosine. Okay? Don't let the fact that there's trig words in there freak you out. It's like saying 3/4 plus 2. Right? That's it. Your common denominator, you need them both to say the same thing. The only way that's going to happen is if you turn them both into cosine. So I'm going to multiply the top and the bottom by cosine to make it legal. So I get sine squared over cosine plus cosine squared over cosine. Okay, now we have a common denominator, so I can smush them together, right? I can have my common denominator of cosine, and then I can look right here.
So then just 1 over cosine, which will be secant.
This equals 1. So I have 1 over cosine, which is secant. Everybody okay? All right, I've obviously picked the harder ones to work with you, right? Number 10, you should be fine on number 10. Number 9, number 8, you should be okay. I said number 9. Everybody good? Okay, number 11. We had one like this in class, but I think it was with sine, right? I'm pretty sure. I also think that on your test, I give this to you as a verify. Let me make sure I'm not lying. Yes. I give you one like this, very, very similar to this, but it's a verify one. So why is that helpful? Yeah, at least you know when you're supposed to stop. And at least you know where you're trying to go to, right? Okay? So this, once again, I have two fractions that I'm adding together, and they don't have the same denominator, okay? So what's my least common denominator? I'm going to go to my first denominator and write it. Is my other denominator different? Yes, I'm going to write it. Trying to make my denominators say the same thing. The only way that's going to happen is if they both say what's written on the denominators, right? So for the first one, it's missing a 1 minus cosine x. So I'll do top and bottom. And then cosine x plus 1 for the other one. So now they both say the same thing. Cosine x plus 1. 1 minus cosine x. And I'm going to write this on that line. I'm going to say, I'm not going to write the ones on the outside because it does nothing for me, okay? I'll just write them so you can see. Okay, so that was me smushing it together, right? I'm gonna distribute that -1 through, so I get 1 minus cosine x.
Minus cosine minus one.
Yep. All over that common denominator. Okay. So up top, that 1 minus 1, that equals 0. So you're left with -2 cosine x over cosine x plus 1, 1 minus cosine x. What do you think I need to do to the bottom? Starts with an F.
Foil.
Mm-hmm. So we'll do first and get cosine x. We'll do outside and get minus cosine squared x. We'll do inside plus 1 last minus cosine x. Cosine x minus cosine x is 0. So here's what I have. -2 cosine x over negative cosine squared x plus 1. You're going to look at your identities and see that if I subtracted cosine squared, what does 1 minus cosine squared x equal?
Sine squared.
Sine squared. Do you see that that's the same thing as the denominator over there? Negative cosine squared plus 1 is the same thing as 1 minus cosine squared? Just written like that? Okay. So I'm going to say this is -2 cosine squared x, no, not squared, over sine squared x. Okay?
Is that gonna be equals to -2 cotangent x, cotangent square x?
Okay, so you're on the right track. It's a little confusing because we have a cosine in the top, right? And then sine squared in the bottom, right? So that's a little confusing. But do you agree that sine squared can be written like this? If I multiplied those back together, I would get back up to the top, right? So this is, do you agree that if I multiplied those at the top, I would get -2 cosine x? Okay? Well, what is cosine over sine?
It's a
Cotangent. What is 1 over sine?
Cosecant?
Cosecant. Okay, this is the hardest one on your test, okay? And then don't forget, this one's a verify. So that at the bottom, at the very bottom, that would be equal to. It would say equal to this, so you would know that you're done. And you would know that you're trying to get it there. And then the one on your test is just a little bit different than this one. Any questions on how I did any of that? Okay. You need to remember, on your test, I'm gonna have one like this. And Miss Kelly told me that I'm gonna find a common denominator, okay? I'm gonna clean up the numerator a little bit. Then I'm going to FOIL the denominator. All right, then I'm gonna use an identity and then simplify. It should work out like that. Okay? Any questions? And if you're freaking out, it's just one problem, so get the other 95 points. You'll be fine.
Where did you get the two from?
Where did I get the what from? Mm-hmm. From right here. So this is -1 cosine x minus 1 cosine x. So that's -2 cosine x. Any more questions about where I got things from? No? Okay. This one should be much easier than what we just worked. What would I do?
Everything is on cosine.
Mm-hmm. What's 1 over cosine?
Secant.
Yeah. So you also have things like that that'll take you like 4 seconds. Okay? So don't think that just because I'm working the hard ones doesn't mean that there's not going to be any easy ones on there either. Okay? Then these are all really good examples. I do have these two starred. So that's crazy that I would do something like that. How would you work tangent plus cotangent? And this is supposed to have an x on there. I'm over here preaching to y'all about writing the angle. I didn't even have one. What would I do to this guy?
Sine, cosine.
Mm-hmm. And that just equals 1, right? Hmm?
Is that both? Would it not equal 1? Is that better, man?
It's not equal to 1. Why is it not equal to 1?
Because plus and I multiply.
Yeah, if we were multiplying,
Oh.
that would equal 1, right?
I mean, you're gonna find the least common denominator.
Mm-hmm.
Just cosine times sine.
Yeah. So what am I going to multiply the first fraction by? Sine?
And the second by cosine.
Mm-hmm. Okay, so that gives me, whoops, sine squared plus cosine squared over,
Cosine times sine.
mm-hmm,
And we know sine squared plus cosine squared is equal to what?
mm-hmm.
Over sine times cosine, we can separate them to 1 over sine times 1 over cosine, which is secant times cosecant.
Yep. Any questions on that one? No?
So you're not finding an answer, you're making sure that it works?
Yes, you're verifying it. You're verifying that one side can be turned into the other side. You're never working on both sides.
Or we can use the other side and do the opposite thing.
Do what?
You can use the other side to verify it by doing the opposite thing.
Turn the right-hand side into the left-hand side? Yeah, that'd be a little more
It's the same
difficult.
thing.
Yeah,
It'd be one over side, or one
you
over
basically
side.
would just work backwards, which is more difficult to do. Because you would be taking one and then you would have to turn it into sine squared plus cosine squared, which is a little bit more difficult than the other way. That's why we start on the harder side and go towards the easier side. Okay, what about 22?
The least common denominator. Turn everything sine cosine.
Turn everything to sine and cosine? So if I did that, I would have
And then it'll keep changing to it.
mm-hmm.
Because sine squared plus sine squared, which is one.
Everybody okay? Yeah? Okay. Then I'm giving you 4 sum and difference. I've highlighted 4 of these. I would write down these 4. This is kind of how they're going to be. Okay, 25. Find and simplify sine of pi over 2 minus x, okay? So this is a minus b. So you would go to your sheet and you would look for sine a minus b, and it is sine a cosine b minus cosine a
Sine b.
sine b, okay? Pi over 2 is what in degrees? 90. So if that's easier for you to think about it like that. So sine of 90 cosine x minus cosine of 90 sine x. Okay? 90 degrees is right here. What's the point right there?
0, 1.
0, 1. Sine is x or y?
Is it y?
Y. So sine of 90 is
1.
1 times cosine x. What's the cosine of 90?
0.
0 times sine x. Well, 0 times anything, 0. What's my answer?
Cosine x.
Yep. Any questions on that one? Shouldn't be too bad. The one on your test, very, 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 very similar to that one. All right, what's the next one? Also, super, super similar, I think. Yeah. I'm really too nice. 1 pi over 12. 1 pi over 12? Yeah. Pi over 12. You know anything about that?
180.
Yeah, I don't really know much.
Or pi over 1.
Mm-hmm. Let's turn it into degrees so we know more.
Okay, 15.
15 degrees.
Yeah, doing the sine of 60 minus 45.
Mm-hmm. Or what? 45 and 30. That's what I have written down, so we'll use that. But if you use 60 minus 45, same answer. Okay, so that's A minus B. So you'll go to your
B sine A,
same thing that we just did, right?
cosine B minus
Yeah.
cosine A, sine B,
So we get sine
45
45 cosine 30.
minus sine 45 sine 30.
Let me draw triangles for you. Okay, you should have these written down somewhere on your test. Once you get to this point, you're gonna have to use them. So just jot down your triangles. What's the sine of 45?
1 over square root of 2.
Mm-hmm. What's the cosine of 30?
Square root of 3 over
Cosine 45?
1 over square root of 2.
And then sine of 30.
1 over 2.
And then we can multiply them. They have a common denominator, so we can smush them together. Like that. Questions? Comments, concerns?
With the 1 over 12 pi, you just multiplied the pi.
Times the 1, yeah. Yeah. Because it's like this. 1 over 12 times pi over 1. So you just smush them together, yeah. Everybody okay? All right, what about something like sine of 135?
We should do the same thing, but pi over 180 or?
No, it's already in
Oh, it's already
degrees. Yeah.
It's like 90 plus 45.
Yeah. It ends in a what?
5.
So we use what?
45.
45. So we're going to say, we know that we want to do sine 45 degrees plus something. So we're going to say, okay, 135 minus 45, and that gives us, is it 90? Yeah, I'm not a calculator. What number is this?
That was 30.
31. So that's 45 plus 90,
It's A plus B.
sine A plus B. So So you'll use your sheet.
Sine
And
A cosine B plus cosine A sine B.
Mm-hmm. Did I write it backwards? Sine 45.
A cosine B cosine A sine B.
There. You can look at those too long, it'll mess with your head. There's 90. Sine of 45 is what?
1 over square root of 2
Mm-hmm.
times 0.
Yep, cosine is x, so that's 0. Cosine of 45 is 1 over the square root of 2.
And then 1 for the sine of 9.
Mm-hmm. So that's my answer.
1 over square root of 2.
1 over the square root of 2. Everybody okay? If it ends in a 5, use 45. The one on your test will end in a 5.
What were you saying?
If it ends in a 5, like 135, use 45. And the one on your test will end in a 5 as well. So you'll use 45. Okay, this one is backwards. So I'm going to give you one that's backwards. This is sine A times cosine B minus cosine A sine B. So you're going to look on the right-hand side of your equal sign on your sheet that hopefully you have in front of you because I don't have it up here.
It's going to be sine A minus B.
Sine A minus B.
Be sine 42 minus 12 would be sine 30. It's equal 1 over 2.
33. Okay, everybody understand that this is sine A minus B. Going from right to left on your sheet. Okay? A is 42. B is 12. If I subtracted those, I get what? 30. Okay, well, you should have this written somewhere. What is the sine of that?
1 over 2.
Yeah, a half. The sine of 30 is a half. Opposite over hypotenuse. The one I give you, very similar to that one. Everybody okay with these 4? These should be pretty easy. These should be the easy ones. But they are the most ignored because y'all are worried about everything else. But you still have to get all these points. There's 20 of them right here. Okay? And then surely you guys can get the double angle ones. You literally just have to read the sheet that I give you. That's it. Okay? Any questions, comments, concerns? Okay. This is the last test before our final exam, so it is important, like, as of right now, don't start packing up. I can hear you getting antsy. I'm ready to go too, okay? See, I forgot. And it's probably going to be good and helpful.
About the
You
exam?
were talking about that.
Y'all are like, no, please remember if it was helpful. If it wasn't, we don't care. Your drop grade, like all of this stuff, like we've reached the point where it's like, okay, let me stop recording.